People talk about context windows like the problem is size, when most of the time, the real problem is contamination. Hi, everybody. I'm Rached, an engineer at Fabrix.ai. Last time, we talked about how context quality or purity, not just size, is one of the core reasons agents fail in production. Today, I want to go deeper on that, but before I do, I'd like to make sure we have a shared picture of what's actually happening when an agent works. There are actually two things going on. The first is the conversation, the back and forth between a user and the agent across multiple interactions. I say something, the agent does stuff, comes back with a response. I send a follow-up, or maybe a whole new query, and the agent does something else and sends another response. Back and forth and back and forth. This happens a lot in interactive sessions, but can also happen with autonomous agents that are interacting with other agents or complex systems. The second is what I like to call the Agentic Loop, what happens inside one of those interactions before the agent produces any output at all. The agent receives a request and it goes to work. It might make 15, 20 sequential tool calls. It queries a database, checks a ticket system, pulls some logs, correlates the results. All of that happens invisibly inside a single turn before anything comes back to the user. At each iteration of that loop, the LLM is deciding if it's ready to produce a final response or whether it needs to call more tools. These are structurally different things, and they have structurally different context problems. At the conversation level, the naive approach is to prepend the entire conversation history to every new turn. You can see why that breaks down, because that conversation history just grows and grows. It usually contains every prompt, every tool call result, and every response. That gets really big, really fast. But it's not just a size problem, it's a purity problem. Most of that history isn't relevant to what's being asked right now. Turn 15 doesn't need everything that happened from turn 1 through 14. What it needs is a targeted, relevant summary of what came before. But summaries are lossy. When you summarize, you have to decide what's important and what's not, aka relevance. Most of the time, they just hope the LLM will automatically summarize the right way. Wishful thinking. But it doesn't have to be that way. Relevance can be determined not by the past, but by the current query. What's being asked right now drives what's included in the summary. That's a fundamentally different thing than basic summarization. Getting this to work properly can be a little tricky, and we at Fabrix.ai have spent quite some time devising clever techniques for producing continuously relevant blurbs. But the main key is that these are generated at the beginning of a turn rather than at the end. The failure modes this addresses are real, by the way. Long sessions lose track of reference and prior context with what we'd call conversational context decay. And if you're loading all of your agent instructions, regardless of what it's being asked to do, you get instruction bloat that muddies the pattern and burns tokens. So you also need to think carefully about what instructions are operating at any given point in a conversation. Ideally, you want to be able to load and unload instructions dynamically. At the agentic loop level, the problems are similar, but they're different in character. Start with tool visibility. At any moment, which tools is the agent aware of? If you expose everything at once, you're burning tokens, describing tools that aren't relevant to this task, and you're increasing the chances that the agent will make the wrong choice. Dozens of available tools creates cognitive overload. And remember, that shapes the pattern the agent is trying to complete. The model has to reason about all those tools, whether they're relevant or not. Then there's tool response volume. A database query might return 10,000 rows. You don't want that in the context window. You want it cached externally. With the agent receiving a summary and a reference ID, it can probe and explore that result on demand if it needs to. But it doesn't sit in the context polluting the pattern. If you do need the LLM to examine a large amount of data, you want to think about how that data is structured and whether it's the kind of language-like thing that LLMs are particularly good at handling. And you want to think about whether there are a bunch of token-inefficient artifacts in this data that you might want to strip out. HTML, for example, is pretty easy for an LLM to understand, but most of the time you could strip out all of those characters and just leave the text, because that's probably what you actually care about. Or sometimes some of your tools may return a JSON structure, but it might make sense to reformat it as CSV, a little bit easier to work with and more token efficient as well. So basically, same root cause across both sets of problems. The context is filling up, but with stuff that hasn't earned its place. But since the mechanisms are different, the solutions have to be different. But the goal is always the same: maximum signal, minimum tokens. At Fabrix, we address this through what we call the Context Engine. It has a few distinct pieces. Conversation compaction handles the conversation level, generating targeted, query-driven summaries rather than prepending raw history. Intelligent caching handles large tool responses, keeping them out of context and making them explorable on demand. Dynamic instruction loading makes sure the agent only sees the instructions and tools that are relevant to the current task. And inter-tool communication allows tool outputs to be shared directly between tools without having to pass through the LLM. But that's a topic for next time, because it has to do with a whole separate class of problems that we'll talk about. Next time, we are going to talk about tooling and what happens when your agent has to coordinate between tools from a variety of different systems. And those tools have no way to talk to each other, because the naive solution to that one is surprisingly expensive. We'll see you on the next one.